It is our honor and delight to have with us today a very innovative company in the field of conversational AI and intelligent chatbots, if I can put a different title to that. Omilia and Themo, I'm really glad that you accepted our invitation, and I'm really happy to have you with us today and hear what you're doing. So the floor is yours.
Thanks everyone for being here. I'm Themos Stafylakis, head of machine learning and voice biometrics at Omilia. This will be the outline of my talk, a brief introduction to Omilia and the Omilia Cloud Platform. I will then talk about Omilia Conversational AI more generally and task-oriented dialogue systems, a brief description of the individual components of the system, and a couple of demos. And if I have time, I'll talk about some research effort Omilia is doing in collaboration with universities. Omilia was founded in 2002 by Dimitris Vassos and Pelias Ioannidis. Omilia creates automated dialogue systems for customer care via voice, text, social media, and other communication channels. Omilia is about currently 2,060 people, mainly in Greece, Ukraine, Cyprus, Azerbaijan, Czech Republic, and USA. Omilia clients are some of the largest financial institutions, telecommunication, healthcare, insurance organizations, retail, e-commerce, restaurants in US, Canada, EU, and Ukraine. During the last few years, Omilia is focusing on its cloud solution, Omilia Cloud Platform, OCP. Recently, Omilia was classified by two big consulting, let's say, firms like Gartner and the IDC as one of the leaders in this domain of conversational AI. So briefly about Omilia Cloud Platform. Omilia Cloud Platform is a conversational AI platform for customer care that requires zero coding skills. It offers an enterprise-scale customer service automation. It works across voice and text channels, offers hyper-tuned out-of-the-box industry models, and ready-to-go integration with most leading call center as a service platforms. We also have Spiro Metheniti with us, who is head of OCP product team. So if you have any question later, Spiros may also address it about this OCP platform. In terms of architecture, as a typical conversational AI system, it offers speech to text to translate spoken language to accurate text, natural language understanding, so that to understand the semantics of the captured, let's say, text, such as intent, entities, dialogue acts, relations. Voice biometrics to validate and authenticate user's identity based on the voice characteristics. A dynamic dialogue management for associating an intent with the desired outcome, planning dialogue, and tracking context. Also, it comes with pre-built skills based on billions of real interactions with users, which are distilled into a hyper-tuned, ready-to-use model. Finally, text-to-speech, okay, in order to generate dynamic speech that sounds human-like. So Omilia prepackaged solution comes with a fully preloaded intelligent virtual assistant, providing out-of-the-box recognition and understanding of all key concepts of a specific domain and language. These pre-built packs come with concepts, annotation dictionaries, rules, and intents. You can see here some of the industry skills such as banking, healthcare, telecoms, and retail, and others. You may also see, for example, for the banking domain, some predefined intents, and also some dialogue flows that the client can use directly. or adapt them to their own needs. OCP also has unlimited channel integration with channels such as WhatsApp, Facebook, Skype, and so on, both text and voice-enabled channels. Now, a central concept in OCP is the mini-apps. Mini-apps are essentially, consider them as applications that are highly tuned to solve very accurately very specific tasks. Say you want to recognize alphanumerics, for example, or amounts or dates. You have a very fine-tuned, in this case, an ASR system, speech recognition system, okay, that has performance that no, let's say, generic solution can offer. There are also the intent mini-apps. These mini-apps are dedicated to capture the intent of the user, so they involve a lot of natural language understanding, and they combine machine learning, deep learning models with a rule-based system. And you can also fuse these two systems to get the best of the two worlds. Here is an example of a way you can go and train, let's say, an intent classifier. Here's an example of, let's say, a pet shop that, and you can just go there and define your own intents. Put there some utterances representative for the particular intent. And you can just train a machine learning, state-of-the-art machine learning model this way. And yeah, it's trained in a matter of minutes or so. And then you can put that into your whole desired dialog flow. So this is based on it's done via the orchestrator of the OCP, where it essentially provides also a nice graphical user interface, where with simple drag and drops, one can define the desired dialog flow. It offers, let's say, nodes such as condition, for example, to differentiate between branches, nodes such as anything else I can do for you. And of course, the mini apps that either you created or the predefined mini apps that are relevant to this domain. And Orchestrator also offers a way to test live what you've created there with this Orchestrator chat. So you can go directly there and write and see if the responses of the systems are the desired ones. Okay, a little bit more now about the individual components of the system. So conversational AI, this is a very generic, let's say, diagram. It can support either, let's say, voice or text. In the case of voice, you obviously need automatic speech recognition and ASR model. But in both cases, you need a natural language understanding so that you extract the semantics. Optionally, in case there is a need to authenticate the speaker with voice biometrics, there is this branch that does so, and everything, let's say, leads to the dialogue manager, which is typically, let's say, the brain of the whole system, and tracks the history of the dialogue, and also communicates with a backend application, which can be, let's say, a database that stores details about the account of the users, right? The dialog manager also generates semantics that are passed typically to a natural language generation, so that it turns these semantics into a text. And in case we're dealing with a voice-enabled system, there is this text-to-speech, okay, to turn them back into a human-like speech, synthetic speech. So our ASR system, first of all, apart from the ASR that is used in this application, we are also offered transcription service. So this is an offline process, and you can upload, let's say, archives and dialogues, and our ASR will transcribe them. Okay, it can be deployed in the cloud or on premise on installation. The domains that we support are, again, financial services, telecoms, healthcare. So our models are highly tuned for these type of applications and domains. We offer features such as context sensitivity and dynamic recognition grammars, rich transcriptions such as confidence scores or timestamps, and customization, both in the acoustic model, but also and mainly in the language model and the lexicon. So you can define, let's say, new words or boost some sentences and so on. Currently, we support about 30 languages and dialects. And it takes us about, consider something like a month, okay, to create a new ASR model that, of course, with time, it will go better and better, right? Our voice biometric solution, here is, recall that the order is here to authenticate user in the background as they speak. So it's a so-called passive authentication. We are not asking the user to say specific, let's say, passwords or so, which is a text-dependent speaker recognition. Here's text-independent speaker recognition. So you can consider us an enrollment phase where the callers are asked to enroll to the VB system. And if they opt in, their voice sample is stored in the VB server, and a voice print is created and stored in the database. Now, consider this voice print as a vector of about 500 dimensions that characterizes, let's say, the voice of the speaker, something like that. So, and it's independent of what the speaker is saying, or at least it should be independent, or the channel, or if it's a noisy channel or a clean channel, or and so on. Ideally, it shouldn't be affected by that, right? At least in an ideal world. So during verification, the VB system samples the speaker and computes a new voice print, which it compares it to the user voice prints that was created during the enrollment. Okay, and generates a confidence, let's say, score, a similarity essentially score. Okay, and based on this similarity score, the dialog manager drives the conversation, and based also on the business logic. It can deliver the self-service, transfer to a live agent, or ask additional traditional security questions in case, for example, of a low confidence score. Okay, we have a small demo here. The first phase will be the enrollment of the user. So the user is calling, let's say, the agent.
How may I help you?
Yeah, hi. I'd like to activate my new card, please.
Yeah, of course. Could you please tell me your member number?
Oops. Yeah, sure. It's 4615.
Oh, okay. They have a natural conversation, right, with the agent. The agent
your
asks,
new card is now activated. Just before you go, I noticed that you haven't yet enrolled in our voice biometrics authentication service, our seamless voice biometrics verification,
etc. So the agent asks the user whether he wants to enroll to the voice biometric service. The user will reply yes, and he will call them back. The system will recognize it. We have also created the instructor voice so that you see how the score fluctuates. See the score.
I'd like to get the balance of my credit card, please.
Sorry, excuse me. I don't suppose you know where Dean Street is. Sorry, you're on the phone. Apologies.
Sorry, no problem. Sorry, could you just give me my balance? I'm sorry, I'm in a loud place here.
And so on. So we are also offering tools to analyze the performance of the voice biometric system through time. In case, for example, you have new deployments, new models, we offer options to filter out, let's say, some calls, some durations, etc., and see in general the performance of the VB system and whether you need to do something on that or whether you're happy or not. Now, the other component, natural language understanding and dialogue manager. Here, the concept, it's basically the extraction of the meaning. Okay, it can be either the intent, as the first example show, like I want to check to access my bank account. This is an access account type intent. There are also dialogue ducts. I want to speak to a customer service, so the systems understand that this person wants to speak to an agent, a human agent, right? There are also repeat requests like balance again, please, or some rejections. Of course, dialogue ducts are context sensitive, right? Okay. We also have entities, another very important recognition unit. Entities can be from account type, airline, amount to redeem, communication channel, anything that can be said and conveys, let's say, a meaning. It can be a sentiment descriptor as well. Okay, in a typical application, you might have more than 100 of such entities. And also there are relations between words, and I will give an example from the domain of food ordering. Now, let's see a demo here.
Hi there. What can I get started for you today?
Hey, yeah, are you guys still serving breakfast?
No, but you can check out our all-day breakfast items on the menu. Let me know when you are ready to order.
Oh, darn. All right. Well, in that case, I guess I'll have the 4-piece nuggets with a Diet Coke light on the ice, please.
Do you want any sauce with your nuggets?
Yeah, barbecue, but can we make that 6-piece?
All right. Anything else?
Yeah. Also, can I have 1 cheeseburger, extra pickle, side of fries, no onions, please?
Okay, that'll be all?
No. Actually, instead of American cheese, can I have cheddar?
Okay.
And 1 regular Coke and another 1 Diet?
Okay. Is that all for you today?
No. Actually, I need to lose some weight, so can I get a salad?
Would you like any dressing?
Yeah, Italian, please.
All right. Anything else?
No, I think that's it. No one else wants anything? No, that's all. Thank you.
Okay, if everything looks correct on your screen, the total will be $11.50. Please pull forward to the pay window.
Okay, so that was a demo from, let's say, the domain of food ordering. Here, it becomes evident the need of, let's say, relation extractor. We have an example here. Can you make the meal with salad instead of fries? So you have to find the relations, and all this should also be based on an ontology, either a generic ontology for the restaurants or specific to the particular restaurant that can be derived, say, from the menu. So we also offer, obviously, text-to-speech, as we mentioned. Our systems are neural, based on neural nets. It's text-to-speech synthesis based on neural nets. It's conversational, TTS, so the voices are geared to be used in conversation in real-world applications. They're able to control prosody based on punctuation. Just a comma, as you see in this, can have a different meaning. And do you want to cancel your card because it's lost or stolen? If you put a comma there, the system will expect different, let's say, information from the user, right? So the TTS should be sensitive to punctuation, right? Ability to voice important information such as dates, digits, and so on, without necessarily the need of this speech synthesis markup language, although it is supported in our system. And ability to control emphasis in order to highlight, let's say, important information in the conversation. We currently offer English, Ukrainian, and Russian. I'll just maybe English now.
Speech synthesis is the artificial production of human speech. A computer system used for this purpose is called a speech computer or speech synthesizer and can be implemented in software or hardware products.
So in this last section, I will briefly refer to some of our research efforts we're doing with Omilia. It's also in collaboration with other universities. This is a non-exhaustive list of the works we have done in the past 3-4 years. Some of our works are related to voice biometrics which we primarily do with University of Brno in Czech Republic. We have done also works in audiovisual voice recognition with Oxford University and Imperial College London. Works in natural language understanding with Athens University of Economics and Business, and other works related. We are also participating on evaluations and challenges for voice biometrics, primarily speaker recognition, the problem of diarization, which is essentially a clustering, let's say, problem. Okay, and also the this issue of creating countermeasures for anti-spoofing. This is related to VB because it essentially wants to capture synthetic voice. Okay, and you need to be able to understand that this voice now is either being replayed or created by, let's say, a text-to-speech or voice conversion system. Otherwise, the systems, the VB systems, can be vulnerable to such, as we call, spoofing attacks. In terms of natural language understanding and spoken language understanding, we have a collaboration with Athens University of Economics and Business, mostly for the capstone projects in their MSc course. Some of the tasks we have worked on are tighter integration between speech recognition and natural language understanding, how to make use, let's say, of several decoding hypotheses an ASR system creates and feed that to the natural language understanding, or other approaches essentially try to get rid completely, let's say, of the traditional speech recognition and go directly from sounds to meaning with an end-to-end, let's say, neural architecture. And other more, let's say, experimental and modern approaches to how to make use of these huge, deep pre-trained language models like GPT-3 and T5, etc. And one of the ways is the so-called prompting, which if you want to do, for example, sentiment analysis and you have an utterance like "no reason to watch," okay, and the task is to say, okay, is a good or a bad review. The more traditional way to do that is extract some sort of sentence embedding with this model and a binary classifier and possibly fine-tune the system. An alternative way of doing that is the so-called prompting way, which essentially says, okay, add a small prompt, it was, and let the language model predict, let's say, which is the next word. And if it's a positive or negative, you can classify, let's say, the utterance based on that. Finally, we are participating in an EU-funded project called Esperanto with several universities all over the world. And one of the work packages we are mostly interested in is working with low resources because automatic systems for speech recognition require huge quantities of data, and there's a lack of annotated data for many languages and tasks. And occasionally these corpora are gender imbalanced and do not contain regional variations. So the goal there is to create and extend corpora for under-resourced languages and tasks, develop automatic systems that learn from limited training data, and utilize novel techniques that combine self-supervision, multimodality, and multilingual training. Some examples of recent works in this direction, if you're interested, are these papers, MSLAM and Speech T5, for those who are interested. And we are also, with this Esperanto project, we will also participate in a workshop that will take place this summer. And it deals with multilingual speech-to-speech translation for under-resourced languages. So we get a target, let's say, under-resourced languages. In this case, is the Tomashek language, which is spoken by about 500,000 people in primarily North Africa. And obviously, it's considered an under-resourced language. And we're trying to see how to combine it, let's say, with other languages that are very rich in terms of resources like English and others, and try these new approaches that create some sort of joint space there, both in semantic, in the semantics, let's say, that combine semantics and speech, and they're somehow language independent. So the ultimate goal here is to create a speech-to-speech translation system based on that. Hopefully you have news from this work soon. And I think this is it. Thank you, and I'll be happy to address your questions.
Okay, so the first question is, can the conversational agents of Omilia recognize their limits and invoke a human customer service agent when necessary? So basically not when requested, but when decide themselves.
Thanks for the question. Yes, we have worked on this issue, and our recognizer understands when we need to escalate to a human agent, and there are various ways you can define that. Even first of all, whenever the caller wants to, can say, "I want to talk to a human or anything, or give me a representative," and the system will escalate directly to a human agent. But there are other ways that you can capture that, okay, probably this dialogue doesn't going that well. Yes. If this is the question, if I understood correctly.
Can I just add
Yes.
to this issue? Is the approach rule-based regarding this switch to human, or is it a trained model?
We are combining both. In some languages it's rule-based, in some others it's combination, some others can be only based on machine learning. So depending on the user, I would say, and the client, how wants to build the system. We are very flexible on that.
My question was specific to the switch to the human operator, if you want.
Mm-hmm. Yeah, I mean, it depends clearly on the particular application. Okay, as I mentioned, anytime you can escalate to the caller can ask to escalate to the user, and the system will understand that. But yeah, whenever, for example, for more than let's say 2 or 3 steps, the natural language understanding cannot find a specific intent. This means that something is wrong with the dialogue, and probably we should escalate to a human agent. So there are various such ways of escalation, the most obvious of which is just have the caller ask for escalation to talk to a human agent.
Omilia can be used for technical support. There are currently companies that offer support by human agents. Is there an estimate of how Omilia performs with respect to human agents?
There is. I don't have the numbers in front of me right now, but we're highly competitive against, in the performance of human agents, right? Yes. But of course, depending on the domain.
Are there any plans to allow usage of third-party speech recognition with the natural language understanding dialogue management of Omilia? Third-party like Azure, Google, AWS. The question is related to small languages that are not yet represented by or covered by Omilia.
I cannot tell right now if there is such an option. We are obviously open to third-party solutions, okay, especially if we need to serve a specific language that it's not ready yet by our team. We can offer such solutions theoretically, but for now, all our systems are, based on our development teams. Yeah.
Hi, sorry, this is Spiros, Methenitis, and I think given to the fact that we are able to train a new model in very limited time, I don't think that this is in our plans. Meaning that if we find the need to have a new language in our offering, then we have all the tools we need, assuming we have access to some data to train our own model. So one of the powers of Omilia is that all technologies are proprietary, and by using third-party, services, takes away a part of the value. So yes, we are very careful on using third-party vendors, right, in our offering from a business point of view, if you want.
Does Omilia support automatic online training and or retraining and redeployment of models, for example, for speech recognition?
Automatic online training, we do that mostly in the language model. Yeah, in the language model of the speech recognition, we do support such an option. Okay, not in the acoustic model. The acoustic model requires other type of process. Yeah.
Can you give a bit more information about this automatic training? What does automatic mean? I mean, how do you get the new data for the online training, and how do you get the labels for the data, and do you need labels and so on?
So I think that based on the question, support automatic online training and the redeployment of models. Well, there are several ways of fine-tuning the language model based on users' data, right? I'm not the right person to talk about this right now because it's mostly for the dedicated ASR team. But we do offer tools so that, for example, the ASR, the language model of the particular ASR can be better fine-tuned to the particular use of the client, right? And I think that's the kind of adaptation we are currently offered to the ASR.
Yes, if I can add a little bit more, I don't know if this is the question, but let's say that, for example, we have a need to improve a model, or a customer sees that there's room for improvement, right? He can select a specific export from the data, and this export will go to another tool in order to be transcribed, right? So this is not automatic, but what happens there is, before we give the data to the transcribers, we try to transcribe them ourselves. So once we hit over a certain threshold, for example, if we have more than 98% certainty of the transcription, then we don't give this data to human transcribers. So for example, out of 1,000 utterances, maybe only 30 utterances will go to a human transcriber. In that sense, most of the part is being done automatically. And this data, after being processed and transcribed, is being used to retrain automatically the language model, as Themos said. And of course, we can also use this data later to train the acoustic model. I don't know if this answers part of your question.
It actually created quite a few new questions to my mind, your answer. So you said there is an automatic transcription of a small percentage of the data, and then this newly transcribed data is used for improving the model. Presumably, only the cases that you select to manually transcribe or manually annotate, I would say, are useful for improvement, right? Because the rest of the data are, they just confirm what the model currently does. Is that correct, Spiro?
Yes, in a sense, but for the acoustic model, but because for the language model, maybe because the sequence of the words is, the n-grams, etc. Maybe it's not present in the language model, and it will be updated, enriched with this new way of expressing the sentence. So the ASR would pick it up, would transcribe it correctly, and this specific sentence with these words in the specific sequence might not exist in the language model. So in that sense, it's an addition in the language model, right? Which was transcribed automatically, if you want, by the ASR.
There's another question which says, does Omilia provide components to other companies to incorporate in their systems since they are state of the art?
We are currently not doing that, but we are always open to such suggestions, but currently we're not doing something like that.
Until now, we don't have a use case, but what happens now, for example, is there are these big telephony providers, call center as a service type of organizations that want to offer, for example, our voice biometric solution as a native offering of their service. So I wouldn't exclude that, right? Because actually we're sort of under similar discussions. And this is a big win for us. It's the opposite of what we were saying. Like, instead of using third-party components, we would offer our technologies to someone else to use it, right? So
I'm not a computer scientist. I am a medical geneticist, essentially. But I have two questions related to your talk. The one question is, are there any efforts of voice recognition in the animals, like dogs or cats or birds? And the other one is, I have posted a video, a famous video, where they are in the elevator, one guy, British and Scottish, and there's a voice recognition in the elevator. It's very funny, actually, and it's a very nice joke, but it is related to the voice recognition. So I mean that there's sometimes the accent, or especially the accent, or the way the people speak, it makes difficulties in the voice recognition, right? There is still a problem, or no? The video is from 2010. Apparently, technology has improved. But I guess
the video is an exaggeration with the 11 instead of 11, right?
Of course.
I believe that even speech recognition systems for elevators will be able to understand that the 11 is 11. After all, it's just close set digit identification. It's not even continuous speech, right? So, yeah. So from this perspective, yeah. But I understand people with different accents might face issues. It's still a problem. It depends on your training data, clearly, here. Even if you have a huge, let's say, neural network, etc., but your training data is totally biased in favor of a specific way of specific accents, let's say, yes, the neural network won't save you. And you still have these issues with misrecognition on these, on these people with different accents, right? Now, regarding speech recognition, first of all, there are works, since you mentioned birds, there are words that aim to classify birds, not to understand maybe what they say, but differentiate between species of birds. Right. Yeah.
Dogs?
There should be some works. Yeah. I'm not very familiar right now with telling you, but I've seen now and then some attempts trying to do some sort of speech recognition for animals like dogs and cats. Yeah. Yeah, that's true.
As a researcher, I find it very interesting, actually. There may be things that will reveal many new things we don't know. Anyway.
Yeah, very good point. Yeah.
But if you want me to add something on top of this, a real life example. First of all, as Themos said, it depends on the training data, right? But the models we offer are not language-based, they are local-based, right? So we have a different model for South Africa English, different model for United States English, different model for Canadian English and UK English, right?
All
So
right.
this is not only to capture, this is not only a different language model, because they use different expressions maybe, but also a different acoustic model because of the pronunciation. But for example, a real life example we have with one of our biggest customer in the United States, which was across the whole United States. But what they were doing, they were opening the regions one by one, right? So we had a very high accuracy until they open up the South regions, right? So when they open up the South regions of the United States, you know, with these heavy Texan accents and things like that, and expressions maybe, then there we saw a small decline in the performance, right? A small decline in the performance, but it's evident it was because of, you know, different region and different accents, right? So what we did is just we added some more data coming from those regions, and the accuracy went back up. I mean, that's it. I don't know. I thought it would be nice to provide an example of a real life scenario, right?
You're right, Spiro. Thanks. Thanks a lot.
All right, thank you.
The question is it possible that Omilia Cloud Platform works as an integration with home automation applications?
Spiro, what's your opinion on that?
Not in our roadmap. Not in our plans. I mean, what we say is that, you know, we're very good at what we do, and what we do is customer care, right? For now, at least. And this is what OCP Cloud is doing. And all these nine, I mean, if you want to know more about, just one sentence about the OCP product, it's because all these nice things you saw before the OCP products needed teams of 30, 40 people working for 6 months to deliver a project for a, you know, big financial institution. So this means a couple of $1 million in setup fees, right? Apart from the running costs, right? When we turn the traffic on. So only a handful of companies globally could offer this kind of investment, right? What OCP does is sort of democratizing this. So it offers this as a service. So you have to pay nothing as a setup fee, right? And you pay as you go, right? That's it. So this is our big goal here, to democratize. I mean, to offer these technologies to everyone, even you know, small companies and medium-sized companies, and in a way that it's also easy to use, right? Like you don't need a 6 months training to build an application, right? This is the vision, right? And the big difference between the on-premise offering we had before compared to the OCP offering, but it's focused on call centers, right? And we don't have something in our roadmap or in our vision to go to, you know, home automation.
Are there plans to extend the functionalities to focus on people with disabilities? It would be very helpful.
People with disabilities. In my research domain, I have done. I spent 2 years working with lip reading, and the focus of this work was primarily for people who cannot speak because of some tracheostomy or something like that, so that they cannot speak. And yeah, I mean, audiovisual recognition or visual recognition case is an example of how to use machine learning, okay, to enable people with disabilities, okay, communicate with a system like that. Currently, though, it's not really in the roadmap of Omilia to work on this direction, at least currently. But thanks for raising that.
Thanks, Evo. Let me add something to that. We have to distinguish whether we are talking about the callers or the users of the service. Because for the users of the service, I mean the ones who use our user interfaces, either this is the web chat or the user interface that you use to create an application, We are in the process, this is in our roadmap, to be WCAG standard. If you know, it's a global standard for user interfaces for people with disabilities. So we would be shortly compatible with this standard for the user interfaces. And for the callers, we don't have something specific in place, but for people with disabilities, as Themos said. But I think we have the tools to enable the application developers to transform an application into an application that is compatible with people with disabilities. I will give you an example. Let's say you're the application developer and you say, welcome, how may I help you, right? And no input, right? You hear nothing. Please tell me in a few words, how can I help you, right? Nothing. Then you can decide, right? Either you transfer to an agent, or, for example, as an application developer, instead of transferring to an agent, I could go and have a third prompt and say, if you have trouble speaking or some kind of disability, then press this number, right? And then they would press this number, and then I could lead them to a totally new menu, which would be DTMF based, right? Like the old ones we had, with very limited options, but the top options that the callers use, hoping that we would assist him in that way, right? And we have similar examples. So we put the responsibility in the hands of the developers, right? Of the guys who deliver the technology. And I think they have some tools in their hands to address some of these issues.
You mentioned the company's roadmap and vision. It would be great to tell us more. What are the next goals for Omilia, and which are the main business directions?
Well, that's a big discussion. I will tell you the pillars that our vision and our roadmap is standing on. And as I told you, is to make it affordable to everyone, easy to use, so anyone can use it, and offer different levels of users, right? You can always have advanced options for the power users, but we have to acknowledge that there is a large amount of people who don't want to do crazy things, right? They just want simple things, and we want to enable them as well. The big challenge here is to follow these two first pillars by making sure you don't sacrifice human quality interaction, right? Which is very difficult because in a sense, there are opposites, right? Easy to use and affordable. It's opposite into offering a human quality interaction. But the challenge is this exactly, right? Not to sacrifice the quality, but at the same time to be able to offer these technologies to everyone, not from a financial point of view, but also from a technical point of view. That's it. And of course, at the same time, we need to build because our cloud offering is new, right? We need to work to continue to work towards our resiliency of the platform. Because people rely on us, right? I mean, organizations rely on us because having a cloud means that we do not only offer the software, we also offer the hardware, right? So if we fail, a part of their organization fails as well. So we need to make sure that we are able to offer these 3, 4, 5 nines, right? If we can.
Thanks, Spiro.
Any more questions? I have several, but as always in these presentations, I tend not to have the time to ask the questions, which is okay, which is good. I like it that there was so much interest from everybody who was here. So I would like to thank again Themos and Spiros, and thank everybody who participated so actively. Hope to hear even more good news about Omilia in the recent future, and have you with us in the future. By the way, you can also participate in the upcoming talks by other companies. You can join our list, our mailing list, and get information. Thank you again very much, and have a good afternoon.
Thank you.
Hi, everyone. Thanks a lot for joining.